We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
So today we'll study about first what is heat exchange. Heat exchange is a process from which the heat gets transferred from high temperature to the low temperature. So the content of the today's topic will be introduction of heat exchangers, classification of heat exchangers, details related to various heat exchangers, type of flow arrangement in heat exchangers, and lastly we'll study the most important topic, that is LMTD calculation. Now we'll first start with the introduction part of heat exchanger. As we know that heat exchangers are an efficient device in which the process of heating or cooling occurs. The main function of heat exchanger is to provide flow path for hot and cold fluid without mixing of fluid, or with mixing of fluid also, that we'll study in the next few minutes. There are different type of heat exchangers that are used in different installations such as steam power plants, chemical process industries, air conditioning, refrigeration systems, furnaces, etc. So safe design helps to decrease initial cost, operating cost, as well as maintenance cost. So our main focus would be to just optimize the design of heat exchangers so that our initial cost would be as low as possible. Operating cost and maintenance cost would also be optimized respectively. Now the next slide is our classification of heat exchangers. We can classify heat exchangers based on the 3 main principles. Based on the principle of operation, second based on flow patterns, and third is based on the function of heat exchangers. Now here comes, if we see that the heat exchangers based on principle of operations, there are 3 types: recuperative, regenerative, and direct contact type. Recuperative type is the heat exchanger in which the hot and cold fluid are separated by a wall from which the heat exchange takes place. And second, regenerative type, as the name suggests, it is regenerative. We are regenerating the heat. So first what it is done, like the hot fluid gets entered into the heat exchanger, and the adsorbents they keep the heat intact in it, and after that when the cold fluid is passed through that heat exchanger, it releases that heat and gives to that cold fluid. So it is regeneration of heat. The regeneration of heat is involved. So we call it as regenerative heat exchangers. Third one is direct contact type. In this, both the hot fluid and cold fluid, they are in direct contact with each other. They are not separated by any partition. So this is direct contact type of heat exchangers. Now next one is based on flow patterns of fluid. It is very common and we used to study before also, that there are three main types of heat exchangers based on flow pattern, that is counter current, co-current and cross current. In counter current, both hot and cold fluid moves opposite to each other. In co-current or parallel flow, both hot and cold fluid go simultaneously with each other. They go parallel to each other, or we can say. Whereas in cross current flow, the hot fluid and the cold fluid moves 90 degree to each other. We will study in details about the calculations also in the next few minutes. Third one is based on function of heat exchanger. Heat exchanger means it doesn't like it heats something. We can also cool something. It is heat exchanger, exchange of heat, whether the release of heat or gain of heat, both are due to heat exchange. So based on the function, it is a condenser, evaporator, etc. Now we'll study heat exchanger. So we'll start with shell and tube heat exchanger. It's very interesting. As the name suggests, it has one shell and set of tubes, which is called tube bundles, and it is intact in a tube which is called tube sheet. Tube sheet has holes in it in which the tubes are welded, and the tube sheets are also mainly of two types. Like tube sheets are same, but the pitch, the holes which is embedded in it, it is mainly of two types, like square pitch and triangular pitch. Each and every component has its function, has its own function. So as we can see in the diagram, one fluid flows from the shell side and the other flows from the tube side. It is not any thumb rule that the hot fluid will pass from the shell side only, but according to the requirement we choose whether the hot fluid will remain in the shell side or in tube side, or vice versa. Now the main thing that I want to make you understand are the baffles. Baffles are the plates that are, as you can see in the regular interval, the plates are embedded. That increases, it has a very important role in the shell and tube heat exchanger, that it increases the residence time of the fluid inside the heat exchanger, so that more heat exchange takes place, and it keeps the tube bundles very firm, because due to turbulency there are vibrations that comes in the tube bundles. So it keeps the tube bundles in a stagnant mode, so it is very important part. There are many parts like this which is involved in shell and tube heat exchanger that you can study. The simplest type of heat exchanger is the double pipe heat exchanger. In this, it simply consists of two concentric pipes. One pipe contains hot fluid and second pipe contains cold fluid. So we have inner pipe and annulus, and the fluid flows either concurrently or countercurrently, okay, according to the process requirement. So we have four temperatures. This is very important thing. We have four temperatures in case of heat exchangers. The temperature at inlet and temperature at outlet of the cold fluid, the temperature at inlet and outlet of hot fluid. So in this way we have four different temperatures. Why I'm telling you that this thing, because it is very important to understand the flow arrangement and the concept of LMTD. Now, as you can see in the slide, this co-current flow, the fluid flows in the same direction, whereas in counter-current flow, both the fluid streams flow in the opposite direction of each other, whereas in cross flow, the fluids just moves 90 degrees to each other. So I hope you all are clear with the concept. Now we'll move to the concept of LMTD. What is the full form of LMTD? It is log mean temperature difference or logarithmic mean temperature difference. It is very important to evaluate the efficiency of heat exchanger. Now, as you can see in the slide, the formula of LMTD is delta T1 minus delta T2 upon ln delta T1 upon delta T2. So just keep in mind that this formula will always remain same for both co-current and counter.